Hey guys, it's Mr. Arnold here with our electron configuration video. I know we've just kind of started to get into electron configuration and it's very confusing. My hope here is to show you how do we fill out an orbital diagram and how do we determine what element we're using based off of our orbital diagram and the number of arrows relating to the number of electrons or protons in the atom, etc. from there. So we started with last week talking a little bit about the three principle or rules that kind of guide us as we're filling that out. Aufbau principle is the first one, which says that electrons will occupy the lowest energy orbitals first, and that a box or a line on the orbital diagram represents that orbital. We have Pauli's exclusion principle, which simply says that orbital may contain up to 2 electrons, and if there are 2 electrons in an orbital, they must have opposite spins, either up or down, kind of shows us the opposite spins. And then finally we have Hund's rule, which is the bus seat rule, which simply says electrons are going to occupy empty orbitals first with the same spin before pairing up with an orbital in an opposite spin direction. So this is the one where we have up, 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 and then we can come back and fill in down, down, down as we're making the orbital diagram. So just kind of helping us look at what are the principles, what are the rules that are dictating or guiding this. The one thing that you will be given for this is our Aufbau chart, so you don't have to worry about memorizing this, but really what this is doing is helping us kind of figure out where do the electrons go, and all we have to do is follow the line as we go, and then we fill out those orbital spots. The s orbitals all have one orbital or one box or line. They can contain up to 2 electrons. The p orbitals are going to have 3 boxes or 3 lines. They will have 6 electrons. The d will have 5 boxes, 10 electrons, and then the f's will have 7 or 14 electrons inside of those individual orbitals. And again, each one of these orbitals is showing us the energy level. We're going to start at the lowest orbital of energy, which is 1s, and we're slowly going to work our way all the way to possibly 8s if we go up that high or that far from there. So this will be given to you. You just need to know how to use it and how to actually read it. We're also going to take a look at, and what we need to know is our periodic table of elements. This will be given to you on the first couple of assessments, and then the second unit you'll create your own periodic table of elements that you'll use from here on out. I like this one here because it shows you where the s orbitals are, where the p orbitals are, the d orbitals, and then our f orbitals are our lanthanide and actinide series of elements down at the bottom of the table. So we're just going to pick an easy one right now. We're going to start with carbon. I know it's kind of hard to see probably, but carbon has an atomic number of 6. And we want to know that. So if we were going to look at the square, this would be what our square typically looks like. We know from review this is the atomic number, which is always equal to the number of protons, which is 6. It's also needed because it's going to tell us the number of electrons that we have, which is 6 as well. So if we're going to fill out the orbital diagram for the element of carbon, we need to know what it takes to fill out at least 6 electrons. So we're going to start again with our Aufbau chart. We're going to start at 1s, and remember each s has 1 orbital or can contain up to 2 electrons, and so we're going to start there. We know we have 6. We're going to put our up arrow first, and then since there's no other seats to fill out or no other orbitals to fill out in the 1s, we're going to go ahead and pair it up, but remember Pauli's exclusion says we have to put it in the opposite direction. So we're going to then follow from 1s, follow the line, gets us to 2s. And if you notice, I'm going to go ahead and put these in increasing order, showing that they're kind of going up in energy levels. Again, it's an s orbital. It's only going to contain 2 electrons, 1 up, 1 down. So we have a total of 1, 2, 3, 4 electrons, but we need to get to 6. So we need to come back now and go to the next orbital, which happens to be 2p. the p orbitals can hold up to 6 electrons or have 3 boxes. So we have a total of 4 right now. There's number 5. And according to Hund's rule now, we want to maximize the up spins as much as we can. So instead of putting a down one here, since there's an empty seat, we can go ahead and put an up arrow there. Again, maximizing the same spin as much as we can. It follows Hund's rule. So for carbon, this is what our orbital diagram looks like. 2 electrons, opposite directions on 1s, 2 electrons, opposite direction on 2s, 2 electrons at 2p, but both spinning in the same up direction. And again, this is simply called our orbital diagram. Let's go ahead and try another one again just to show how the orbital diagrams are actually filled out. We're going to go ahead and pick sulfur, which is an atomic number of 16. So if we have 16 protons, that means we're going to have 16 electrons. And so now we know we're going to go a little bit higher up. Remember, we stopped at the 2p for our 6. Now we're going to add more. So we're going to slowly start to kind of creep up in our orbital diagram. So we're going to go ahead and just kind of draw this out. We'll start with 1s. Again, s's get 1 box. We know we can put 1 up and 1 down. That's following our Pauli's exclusion rule right there. We're going to move on to the next one, which is 2s. And again, it's nothing different than what we did up here. We're going to go 1 up, 1 down, which is our 2s. We're going to go ahead and go to 2p. Now, with our 2p, we're going to follow Hund's rule. Up, up, up. Now we can come back and fill down, down, down. Again, trying to maximize the spin in the up direction until we have no other choice then to fill with Pauli's opposite direction on the 2p level. So from 2p, we're going to jump to 3s, and then s's only have 1 orbital, so we're going to go up and down. So we have 2, 4, 6, 8, 10, 12 of our 16. We need 4 more. So if we take a look from 3s, we're going to 3p. We know the p boxes. Our p can hold up to 3 boxes. And so we know that we already have 12. We need just 4 more. We're going to go 1 up, 2 up, 3 up, maximizing the spin according to Hund's rule. And then we are going to then follow Pauli's exclusion and fill back in that last one. So if we take a look here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This is the orbital diagram for our element of sulfur. All right, for our final one, let's go ahead and jump into the d orbital so we can see kind of how that's filled out here. We're going to choose nickel, and nickel has an atomic number of 28, which tells us that we have 28 protons, but then it also tells us we have 28 electrons as well. So that's where we're going to kind of start with from here. Again, we're going to follow our chart, 1s, 2s, 2p, 3s, etc. from there. And we're going to start to fill up to see what does nickel's orbital diagram actually look like. And again, 1s has 1 box. We start with an up arrow. Pauli's exclusion, we put our down arrow. We're going to move up to our 2s, just like we have done in all of the previous ones. 1s, 2s, 2p, etc. We know that we have an up and a down in that one. We're going to move again to 2p. Our p's can hold up to 6 electrons. Up, up, up. Now we come back according to Hund's rule. We're good. Now we're going to come back down, down, down for Pauli's rule. From 2p, we go to 3s. S's only have 1 orbital or box. That gives us an up and down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We've got 12 electrons. I'm just going to leave a little side note there so that I don't mess up my counting. From 3s, we go to 3p. And again, we have 3 boxes. We're going to follow Hund's rule, the bus seat rule. Make sure that we maximize our up spins first. Come back, fill in with Pauli's rule the down ones. So we've just added 6, so we're to 18. We still need to get 10 more electrons in here. Now, most of you might think that we go to 3D next, and that's where we need to know Afbau's chart. Because Afbau's chart says after 3P, instead of going to 3D, that we actually go to 4S. And that's because 4S actually contains a lower level of energy needed to contain those electrons in there than 3D does. So we actually are following Afbau's principle by filling out 4S first, because it does have a lower energy needed than it does for 3D. So 4S is going to be our next one. And again, it's an X, or an S, sorry. So it's going to get a 1 up, 1 down. Now we've got 20 of our electrons going. And again, according to our chart, from 4S, if we just follow the line, we're to 3D. The Ds can contain up to 10 electrons, which means we need to have 5 boxes. And remember, we still need 8 more electrons. So we're going to follow Hund's rule, up, 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 up. Maximize our up spin first. 1, 2, 3, 4, 5. Now we need 3 more. Down, down, down. So this is what nickel would look like if it was filled out correctly for our orbital diagram. We have 1s, 2s, 2p, 3s, 3p. We bounce to 4s because it's got a lower need of energy than 3d, and then we came back in and filled in 3d from there. All right, so these are orbital diagrams for carbon, sulfur, and nickel. As long as you follow Afbau's chart, as long as you put 1 box or 1 orbital for the S's, 3 for the P's, 5 for the D's, and 2 for the F's, you're going to be fine. If you have any questions, let me know.